So how we identified that this one is a simple linear regression model. As you can see, we are having a data frame, right? And the data frame name is company profit.csv. We are having the startup year of operations. I'm just giving you a quick overview at what all we have covered till now. So this is nothing but the startup year of operations, and we are having the profit here. So what does that mean? Startup year operation means that we are having, let's say, startups, and after the operational years, what kind of profit they are giving, right? So we were trying to find out the simple linear regression model, and we are trying to check that how much accuracy this data set is going to give me while training it. So we have done the splitting of X and Y, where X is your input column. In our case, it is going to be startup year of operation. Y is going to be your target feature, which is the profit. Now, what is the next thing? From sklearn.model selection, we were splitting the train test into X and Y, which means X train, X test, Y train, Y test. Simple. Now, this is your linear regression model, and we fit the data set inside this linear regression model, and here we are having the calculations for the prediction. Yesterday, I told you that there is a possibility that these two values are never going to get matched. That's why we never calculate the accuracy score on the basis of Y pred and Y test. We always calculate the accuracy score on the basis of Y train and X train. Why? Now, since my model is learned already, okay, after learning, I am checking what is the linear score. Okay, so linear underscore 1 is nothing but my model. Dot score is nothing but that will help me to identify the accuracy of the model. Since my model is, you can see I declared linear underscore 1 here, right? Which means this is nothing but my linear regression model. Now what I'm doing here, linear underscore 1 is telling me the score of the model after getting trained, which is coming somewhere as 0.96 or 96%. Now we plotted the graphs yesterday. This is your, what you can say, best fit line graph on the basis of what? We are having the training data set and we are having the Y train. So for first we have done X train and Y train. We plotted the data points in the graph. Later we plotted the X train. Along with that, what is the Y prediction? On the basis of that, we created a best fit line. Now you guys understand that the distance between the actual data point and the original data point creates the best fit, creates the error, right? So we have seen different type, this is their prediction, okay? We have seen different types of graphs, and now we are yet to find the error for this simple linear regression model, okay? Now understand that error, we are having three options for finding the error: mean absolute error, mean square error, and root mean square error. Let me write it down. Mean absolute error, mean square error, and root mean square error. Okay, so we'll find these three. Understand one thing, that in the linear regression model already we are having some of the methods to find this error. Okay, just a second. Yeah. So if I'm going to import some metric, it will help me to find the mean square error and let's say mean absolute error as well. Okay. These two I can find easily with the help of linear regression or metric library, or module. But this root mean square error is not there. So what I told you, what is the calculation of these root mean square error is, first we have to find the mean square error and then we have to do the root over mean square error. That will create nothing but this RMSE, which is root mean square error. Okay, so I'm importing the library here, which is nothing but the metric. If you guys remember from sklearn.matrix. So that metric is helping me here also again to find the errors. Okay, so just a minute, let me rerun all the cells. Okay, now coming here, what we have to do, simply I'm going to import sklearn.matrix as matrix, since I cannot use or write sklearn.matrix again and again. So I'm just, let's say, aliasing it or giving this sklearn.matrix a small name called as matrix. Now simply I'm writing matrix dot mean absolute error. As I told you, we already have these methods available, okay? Mean absolute error. You can see these are different type of errors available in sklearn.matrix. So which one we have to choose? Mean absolute error. Okay. So simply choosing mean absolute error. If we have to find the error, so it is going to be, let's say, it is going to be the difference of these two data points, right? This is your predicted and this is your actual. So actual minus predicted will give me the error here. That's what we were learning in the previous session as well. So simply I am writing the actual data point and I am writing the predicted data point. Okay. Since I'm going to run this one, you can see this is giving me the mean absolute error. Understand that this is the error which is coming by calculating the distance of the data points which my model predicted and which are the actual data points. Okay. Now here you are not going to say that my model is 96% accurate, which means there is only 4% error in my model. Okay. I cannot make such judgments. Why? Because this is continuous type of a data and making such judgment is not good or true here. Why? Since I am finding the error, it is giving me 6043.48, which is nothing but the average distance of the data point from the actual to the original. Okay. Similarly, I'm going to find the mean absolute is done, mean square error. So I'm simply writing matrix dot mean squared error. Inside that, I'm again going to mention the actual versus predicted. Okay. You can see this is the squared. That's why you can see the number or let's say the value is coming. Bit huge. Okay. Because it is, what you can say, whatever the, let's say I can see the difference here between the actual and the predicted is a bit huge, right? So if I'm going to square that error, it is going to become a bigger value. So it is making the bigger value bigger and the smaller value also bigger. Okay. So since we are having the mean squared error somewhat like this, I am going to do root over this mean squared error. It will give me root mean square. So I can do this with the help of math module, or you can also take the help of numpy. So simply I am importing import numpy as NP, and I am storing this inside the variable MSC. Okay. And if you want to see how MSC is looking like, you can write somewhat like this. Okay. Now, what you have to do is just simply root over MSC. Okay. So I'm going to write np.sqrt. Either you can write this whole line if you want to, or you can simply mention the variable in which you have stored this. Okay. So this is your, now you can see these two values are coming somewhat kind of a similar. This is 6043. I'm not saying similar, which means near to each other. No. This is how many digit number and this is how many digit number. So mean square error somewhere coming as 710. Root mean square error is coming somewhere 7103.2. Absolute error is coming 6043.48. And the mean squared error is coming somewhere as 50455,697, which is the huge value. What I told you guys, if your data set contains no sort of outlier, so you can move forward with mean absolute error. If your data set is containing some sort of outlier, mean squared error. Okay. Once your data sets are closely following each other and most of the data points are far from your, let's say the predicted one, so you're going to choose root mean square. Okay. So in this case, I cannot see any sort of outliers present in my data set. There you can see. So I'm going to move forward with your mean absolute error. Getting the point? Making sense or not? Okay. Yeah, anybody was trying to speak, right?
Can you repeat it again?
Yeah, this outlier point, right?
Yes.
So, yeah, let me write it down. You guys understand that if we are having the outliers, which means the data sets or data points which are very far from the original. You can see somewhat like this. Understand this thing very carefully, guys. Since we are having the data points like this, what do you think? Your best fit line follows the majority. It is not going to follow somewhat like this kind of a line. No, it is always going to be a straight line because we are following the equation of line, right? So this sign or this thing is never going to come into the picture. Okay. So even if you're having the data points like this, what will happen if you're going to identify the error between these some of the data points which are very far away, you will get very heightened value. Okay, which means this is already a huge distance and we are squaring it. So if you are having the data points very far from the best fit line, there is a possibility. 1 or 2 data points will always going to be there. Okay. So 1 or 2 data points are always going to be there. It contains outlier. You can go with mean square error. Okay. Because it will help you to identify the outliers. If it is very far away from your best fit line, you can easily rectify or recognize it by squaring it up. Okay. And now nobody will tell me and why there is a reason why are we squaring it. Yesterday we already had a discussion over this. Since I don't want my error to come in the negative direction, that's why I'm squaring it up. After squaring it up, you are getting huge value. Understand that it is nothing but the data point which is very far away from the best fit line. Okay. So you can choose mean square error. I'm talking about 1-2 data points here. Now, when you're having mean absolute error, which means this is the case which we are having right now. In this case, if you look into your data points very clearly or closely, if you follow it, no data points, since we are plotting Y train, right? X train, Y train, and we are also plotting X test. I cannot see any data point is going very far away from the best fit line. Okay. So in such cases, when all of them closely following the best fit line, not very far away, I can choose mean absolute error. Okay. So since you are having some of the outliers, mean square. When you are having no outliers, mean absolute. What is the root mean square error? It is just normalizing your mean squared error. Since you can see the value of mean square error is coming way too much, very huge, right? Just to make it short or just to try to normalize it, you can do the root over of this. Also, if you are having multiple values like this, which are acting as the outliers, by default you will understand that your MSC value will come very high. So either way you have to normalize it with the help of root mean square error. Now getting the point? Yeah. Okay, so if you look into the data set, you can see that we are having the data set of e-commerce customers, and this is the customer data set. Okay, where we are having one column as email, another column as address, and we are having the third column which is nothing but one avatar, fourth average session length, time on application, time on website, and length of membership. Okay, yearly amount spent. Now these are your features, or let's say different columns available in the data set. Okay, as you can see, now I'm going to write the problem statement or case study based on this. You will understand what we are trying to achieve. What is the ultimate goal, you can say. Okay, so let me write it down. The data set contains data of customers who buys clothes online. Okay, now you can see it is directly telling me that it is containing the data of customers who usually buy clothes online. Okay. Now, the store offers in-store opportunity, or let's say in-store style and clothing advice sessions. Okay. So basically you can consider that I have a website, okay, online website. But if you want to visit the store for giving the, let's say, consider this as a boutique, okay, we are having the styles available in the website. But since you want to buy it, you want to take some advice on the fashion, you want to give your, let's say, size, if you want to give your measurements, you can visit there in store as well. Okay. So clothing advice session on the styling, for the styling purpose or the measurement purpose, you can visit there in store as well. Okay. Now, customer come in, or let's say customer come into the store, have sessions, or let's say meetings with a personal stylist. Then they can go home and order either, or let's say order product either on mobile application or website. For clothes they want. Okay. The company is trying to decide whether to focus their efforts on their mobile application, experience, or their websites. Understanding the point, the company offers the online service on both the portals, or you can say on both the devices. You can have, or you can access their website via desktop, or you can access their websites with the help of mobile application as well. Simply the difference is that you have to download the application from either App Store or Play Store, and then you can have in the application in your mobile and you can use it. Otherwise, if you don't want to download the application, you can directly open their website on Google Chrome or any other browsing, let's say, search engine or browsing area, and you can use it. Okay. So the point here is that what is the business question? Let's say the clients are coming, or the client concern is that where to put much effort, either on the mobile application or on their website, because they are having low budget. They want to only spend on one of these. So which one they are asking which one we are going to suggest them to invest in. That is the question. Okay. So as you can see, if you slightly go up and see your data set, we are having email, we are having address. Okay. We are having avatar, that is nothing but you can say the name of the address. Okay. Now average session length. This average session length is trying to tell you that once you go to meet people in store, how many minutes you are consuming or how many minutes of session you are having with the stylist. Okay. Time on the application, mobile application. How many minutes the customer is spending on the mobile application. Similarly, if they are not downloading the application and they are directly opening with the help of website, how many minutes they are spending there. The length of membership. Understand that, guys. If you remember that now these e-commerce website, they gives you the chance to acquire their membership, where they will help you to give some discounts on everyday purchase or daily basis. Okay, so let's say, for example, your Prime, Amazon Prime, right? So you will see that the sales for the Prime customer starts early as compared to the normal customers. So such type of membership they are talking about. What is the length of their membership? Okay. Now this length of the membership is in the yearly basis. Okay. Now yearly, how much amount they are spending in this overall activity. Okay. So since they are going to buy the membership, it is going to cost something. They are spending time on the application, that is also giving them some profit. The average session length, let's say if you go in store and they are having discussion with the stylist, that is also giving them some sort of, let's say, extra amount, or you are paying them for that hour. So yearly, how much you guys are spending? Yearly, how much the customer, okay, you can see it is nothing but the entries of customer. Yearly, how much customer is spending on all of these activities altogether. This is your target picture. Okay. Now, if you understand what is the concern is we have to either focus on the mobile application or we have to focus on the website. Okay. So you can see two columns are coming into the picture. Time on application and time on website. Understand this thing very, very carefully. When you are having such questions, you will get stuck. Which one to select target column as? Okay. Understand one thing, that even the customer is spending time on application, or it is the customer is spending time on website. What is the ultimate goal? They are giving us some profit on the yearly basis. So understand, yes, of course, these are my two major features, but my target column is going to be yearly amount they are going to spend while using these two features, right? Now we will check which one is getting used more, so that we can tell the customer, our customer, not their customer. We can tell our e-commerce clients that you can spend on application or you can spend on website. Okay, which one is getting used more? Now you will tell me that can't we just judge it by summing their minutes up and finding the average? Can't we do that? So understand this thing, it is not only feature taking participation or the yearly amount spent, right? We are having all the features coming into the picture, which is taking participation, that is helping you to reach the ultimate goal. So I cannot just by looking on the time of application and time on website, I cannot make the judgment. Here you can see the time of application is 12.65. Here it is looking 39.57. I'm saying that, oh, they are spending more time on website. Let's say directly that client should go with the website, not the mobile. No, because there is a possibility, there are multiple possibilities, okay? And every feature is taking participation to get this output. So I cannot decide on the average basis.
But this yearly amount spent, that is spent by client, whether he accessed app or website in total.
Okay, so we are having average sessions as well, and we are having length of membership as well, right? If you are buying membership, you are again spending some amount. Getting it?
Yeah.
It is a collective data of yearly amount spent. I cannot just pick up these two features, find their average and let them know in which to work upon. Okay? I can see the combination of all of them is helping me to create the profit. So I have to pick every feature and allow them to participate. Okay? Maybe they are using website due to storage issue, or maybe they don't want to install the application. Yes, also, there is also the possibility, right? So I cannot directly say that, okay? Or there is a possibility that I have no storage space in my mobile. Come tomorrow, after 1 week, I'm going to buy a new mobile. And you guys know that applications are more convenient than the websites, right? I'll switch to mobile application later someday, right? So we have to think in all the directions then we have to judge how important these two features are, and based on their importance, we are going to tell the client or customer which feature or in which section they need to work upon, mobile application or the website. So guys, do you remember the multiple linear regression approach? What I told you. When we are having n number of feature taking participation, can we write the equation of line somewhat like this? Let's say y equals to m x plus c is my normal equation of line. Since I can see multiple features are taking participation, can I write the equation of line somewhat like this? Let's say m1 x1. m1 is going to be the coefficient of this x1 feature plus m2 x2. m2 is going to be the coefficient of this feature, m3 x3, m4 x4 plus c. Okay, now what is this n coming here, guys? Understand this coefficient is playing a very vital role here because it is telling you the importance of that particular feature. Getting it? Higher the coefficient, higher the importance of that feature. Simple. Making sense? Are we getting the point, guys? Do we have any questions till now? No for everybody? Still, if you are having some questions, you can ask me right now. Okay, so this is nothing but the equation of line. You guys remember that yesterday we were talking about that we are going to plot the x train and y train, my original data points. Then there is going to be one line which is best fit line, and that is going to be the predicted line, right? How this line is getting created? With the help of y equals to mx plus c equation. Now, yesterday we were talking about simple linear regression. Now today we are talking about multiple linear regression, which means our multiple columns are taking participation. So previously, since it was simple linear regression, I was having the mx. Simple. Now since I am having the multiple linear regression, I need to give every feature the m and x, which means m is nothing but the slope or importance, x is that particular feature, m2 x2 this feature, m3 x3 this feature, m4 x4 this feature, where m is nothing but the slope, x1 x2 x3 x4 are nothing but the features. Getting the point? Okay. Now the stage number 1, first we have to check if the data set is following the linear relationship or not. Do we have some linear relationship? Then only we are going to move forward with linear regression, right? Unless I have to choose another model, non-linear model. So let's check that first. I'm erasing this. Now let's try to plot the graph and check if the data set is following the linear relationship among the input and the target feature. Right. So for the plotting purpose, can we say slope here as weights associated with the input feature? Correct. We can say that. Okay. Slope is the coefficient. You can also say the importance of that feature, or you can also say the weight associated with those input features. Okay. How much I'm going to multiply so that I'm going to achieve the output. So import Seaborn as SMS. Right now what we are doing, we are checking if it is even following the linear relationship or not. Okay. So simply I am choosing SMS dot joint plot. Oh, we keep it as pair plot. If you guys remember, pair plot helps you to pick up all the numerical features and plot the graph of those numerical features in the combination. Okay. So SNS.pairplot df. Okay. You can see, ignore the diagonals. Guys, if you look into the diagonals, what information you are getting? Chalo. Let's talk about the data set bit more. Okay. Chalo. Average session length with average session length is creating a graph somewhat like this. What we can call this graph as? Do we have some outliers in the data set? What do you think? Isn't it looking bit of the normally distributed? What do you think? It's very
Yes.
okay. You can ignore 1 or 2 points, but if you see that it is creating a perfect bell-shaped curve, right? Major observation, guys. I'm not talking about it. Focus it very precisely. But if you look, that it is creating a bell-shaped curve. Okay? Since it is creating a bell-shaped curve, which means it is a good thing. Okay? Which means my bell-shaped line is going to cover major data points.
आज के लोअर क्लास में गरीब लोगों में भी अपने सांसें से साफ है.
What is happening? Watching news. Sure. Now, this is the basic observation. Now, what is the next observation? We have to see that any of the input column is creating a linear relationship with my target feature or not. That is the major question. Okay. Average session length, I cannot see here in this row. Non-linear. Everything is non-linear. Time on application, non-linear. Time on website, non-linear. Length of membership. Length of membership is creating a linear relationship with my yearly announcement. As I told you, any one of the input feature should create a linear relationship. Then only we can apply the linear regression model. Okay, here I can see that following a linear relationship. Okay, with the length of membership and yearly amount spent is nothing but my target feature. We are having a linear relationship, so we can move forward with the linear regression. Simple. Okay. Now, if you want, you can, out of curiosity, you can also check the data type of this data set. I'm simply writing df.dtype. Okay. Email is object, address is object, avatar is object. Ignore all of these two because it has nothing to do while finding the target column. Okay. My email address has no association. My address has no association. My avatar has no association for judging the profit. Okay. Or yearly amount spent. Simple. Now coming back to the point, let's distribute the X and Y. We'll directly apply the model. Okay. There is no change, guys. The thing which we have written for the simple linear regression, we have to write the same thing here. Just 2 or 3 things are going to get added. Simple. No rocket science. Very basic. Okay. So let's distribute X. So if you look into the X, what it should be. This is going to be your 0th index position. 1, 2. Okay. This is going to be your 3, 4, and 5. Okay. 3, 4, 5. Hello. Let's write simply df.ilog. I want all the rows, and from 3 to 6 columns. Getting it? Average session length, time on application, time on website, length of membership is getting left, length of membership. So 3:7 is the correct answer. Since it is coming in the format of data frame, I don't want that. I want NumPy array. So I'm going to simply write dot values. It's giving me the array. Now, how do we decide? This is a good question, okay? So how do we decide if the data set is linear or not? Very basic, guys. You can see here the non-linear data set, how we are getting the scatter plot. Somewhat like this, right? What I told you. Any of the input column should create a linear relationship with your target feature. Which one is your target feature? Yearly amount spent. The input column, length of membership. You can see it is somewhere forming a straight line. And if you talk in the sense of correlation, and if we talk in the sense of correlation, what kind of correlation it is? High positive. Okay? Chalo. Why do we convert this into array? Because when we feed the data set inside the ML, and if ML will consider the data set like this, we need to understand one thing, that with this data set, we have the column names available as well. Okay? Column names are string type of data, and machine do not accept string type of values. So we usually convert this into array so that it will not create any sort of issue while I feed this array inside the ML module. Getting it? It will convert this array into the vector one by one and try to understand the pattern by predicting the output. Okay? Any more questions? Let's try to judge y as well. Y equals to df dot ilog. I want all the rows. I want column, the last one, which is yearly amount spent. Okay, we were going till 7. Let's check how y is looking like. Correct. We can also choose -1 as well, guys. There are multiple ways of doing this, slicing or dicing. You can do whichever way you want to. Do this and let me know. Are we good till here? Okay. Now, splitting the train test. I hope we are good till here. Any questions?
No more questions.
Okay. Yeah. Splitting the train test. Simple. What's the first parameter? Here, this colon. Let me tell you. Whenever we use the slicing for 2-dimensional, if you guys remember the NumPy section, what happened? First, we have to do slicing for rows, then we have to do slicing for columns, right? So I want all the rows. So for selection of all the rows, can I simply mention column? If I'm not going to mention starting index position and ending index position, by default Python will think that I want all the rows. Simple. Okay. Now since we want some particular columns, that's why we are mentioning the index position of those columns. Okay. So Let's split the train test, guys, from scale on. This though, write this in your head. Keep this, always remember this thing because this is very repetitive and you guys are going to acknowledge this very frequently. Scalon dot model selection, I'm talking about this. Okay? Import train test split. Okay. Coming to the new line, X train, X test, Y train, Y test equals to, mention your input and target features, mention your test size or train size. Let's try to mention the train size this time. Okay, you can mention either of them, no issues. Previous for all the models, we mentioned the test size. Now I'm mentioning the train size just for the change. I'm mentioning as 0.75. Okay, and mentioning the random state as any number. Okay. Just a second. Is it not taking that? No, it's not taking up equals to.
Viva, shouldn't it be just 70%, 0.7 and 0.330? Because I think we learned na 70-30 if the data set is small and if it is comparatively large than 80-20.
Okay. Just a second. Yes. So what you were saying, that is fine. Okay. If you want to choose 75-25, that is also okay. What I was trying to portray is that whenever you are having the data set very huge, 80-20 is a good option. Whenever you are having data set small, 70-30 is good option. But even if you want to make it 75-25, that is again fine. Let's not go for 60-40 and 90-10. That kind of distribution.
Okay.
Within that range, you can choose anything. I'm making this as test size. Okay. You can make this as train size as well now. Okay. I forgot to mention train test split, that's why.
Can you please, sorry, you explained earlier, this random state is equal to 6. How do we opt for it?
Okay. So if I'm not going to choose the random state here as any number, let's say if I'm going to remove this, simply I'm running this. Okay. Now you will see what your X train is looking like. This. Okay. Just a second. Let me remove values as well. Guys, you don't modify anything, okay? This is just for the explanation. This is your X train. Okay. Now understand, if I'm not writing a random state, I'm again running this cell. You will see 258 is coming in the first section. Okay. You can see now 53 is coming. So if you're not going to fix the random state, what will happen? It is randomly deciding what part should go for the training purpose, what part should go for the test purpose. Similarly for X and Y as well. So if I'm not going to fix the random state, every time the data set will get shuffled. Okay. And every time I'll see some different kind of accuracy. It is not going to.
Got it. So it's a single time we are selecting the random data, but if we run it again, the data will not change.
Yes. So if you mention some random state, this is simply the same as random dot speed. If you have the idea in NumPy, it fixes the randomness of the data. And we don't have any explanation for this number. It just asks for some number which you need to get. That will fix the randomness of the data. I can see if I'm going to run this again and again, it will show me 431 every time. Okay. So I'm just fixing the randomness here. Okay.
Yes.
Now let's go back and simply write that values. So splitting is done. Now we'll apply the linear model. Simple. That is going to be similar as that of yesterday. No difference. Okay. So simply I'm going to write from sklearn dot linear model import linear. You can see logistic regression last, so CV linear regression. Okay. Coming back, saving that in some variable lm and writing linear regression. I'm going to choose this lm variable to fit the data set inside the model. While fitting, we give xtreme and ytreme. Let's do the prediction. Diaped equals to lm dot predict. Inside the predict, we are going to mention x test. Doing the prediction. Now we'll see how my y test and y pred is looking like. This is a y test. Okay. And this is going to be a y pred. You can see the first entry is 553.60. It is 552.60. It is 555.89. It is 559.43. 495. 492. Okay, almost close. Okay. Now, if you want to plot the graph, you can plot the graph. Okay. And if you want to see the linear score, if you guys remember, lm dot score, which you are using X train and Y train yesterday. X train, Y train. I'm saying, but writing wrong. Okay, you can see somewhere near about 98.48. Okay, still we are having some issues with the model, but you can see. Let me change the random state from here. Then to just cross verify if everything is correct or not. 98.45. Change the random state again. .18. It's good. Okay, I'm even changing the random state again and again. Even I'm shuffling the data set. Previously it was 98.45. It is 90.18 now. Why it is coming? What do you think? My data set is very good. You guys have seen it was following the normal distribution. Very less outliers. That's why this is the reason the accuracy is coming very good. Okay. So for the creation of best fit line, guys, we need matplotlib, right? So import matplotlib dot pyplot as plt. Okay. plt dot scatter. I'm going to mention x train and y train there. It is going to point to my original data points. Okay. Now plt dot plot. You will see the best fit line now. X train, based on the X train, what we are having. So you can simply write lm dot predict y train. Is my model learned already? Okay. X and Y is the same size. lm dot predict y train. Okay. It is of same size. Let's fix it. Just a second. it got modified. Just a second. Extreme X test, Y train, Y test.
Maybe it should be lm.predict on extreme.
Oh, yeah. Oh God. Still, it is showing the same size, right? That's the issue. Just a minute. Extreme and white. Okay, so then there's one more. Chain, X and that. No, basically what is happening, it will create a plane, I understand. It's just, I'm not understanding the X train and Y train, why it is different. It should be same rows, right? Same set of rows. Hmm. Wait a minute. Let's just plot the scattered one. Scattered one is also not getting plotted. That's the issue. Let's see. Okay, for this it is coming. They are of same length. Okay. If you want to see the best fit line for this one, I can simply write the y test and I can plt dot plot, right? Like that. Wait a minute. X test, y test. X test, it is going to be there. Sorry. Y test, and here it is going to be just a second, guys. X test and Y test will create the original data point. Okay. Now with X test, we have to do the diagram with the type of plot. See, the size issue is coming. That is the problem.
Could it be because X test has number of columns more than Y test?
Correct. It is because of the column issue that I understand. And it is also picking up different set of rows. That is also the issue. Okay, leave it.
Can you type X train dot shape instead of size? What will be the output?
Shape 375 cross 4. The size was 1500, huh? So it should match.
No, size. I think it took all the columns size to addition.
Multiplied. Right. Got it. Best fit line we have to draw while picking some particular column. We cannot draw this. Since we can see this scatter plot for y test and y print. Okay, so best fit line here is something different. You see? So we are having n number of columns. So y equals to mx plus c carry the different coefficients, guys. You remember? Every column must be having some different slope. So how it is going to plot that? That is the reason. So if you want to see, we can see with the help of this. Get it? We can see the scatter plot. We cannot see the best fit line here. Okay? Everything is fine. I was writing size. That's what the issue is. Shape is correct. So it is creating a straight line for the testing and the prediction. Simply y-test is my original value and y-pred is my predicted value. If I collide them up, you will see it is creating a line. Okay. Since we cannot create a best fit line for this, because you guys know, in the X we are having multiple columns here, right? So for simple linear regression, it is possible. But for multiple linear regression, we can see we are having n numbers of columns, and every column is going to have some different slope. Okay, so it is going to be irrelevant here. And we don't have column name also, guys, if you remember. We already converted that into array, numpy array. So the creation of best fit line is kind of not possible here. We can not directly like this. Okay. Find the error. I'll tell you why is that. So let's quickly find the error first. Just a second. So let me run all the cells first. After this, we will find that how we can answer this business question. Also, we will find or we will talk about the topic which says that assumptions for the linear regression. Okay, which means what all things we have to assume or what all things are the prerequisites before using the linear regression models. Okay, so that is very important topic. And most of the time, people ask you such questions in the interview. Okay, so let's try to find the error first. Since we are doing so many practical things, we will shift a bit into the theoretical one as well. Okay, so from simply I'm writing import sk learn dot matrix as matrix. Then I am finding first thing, which is mean absolute error. Matrix dot mean absolute error. Inside that, you have to give y-test and y-pred. Very basic. This thing we have already done. Okay. What it is giving you 7.72 something. Okay. And guys, if the error is coming bit up and down, it's fine. Bit I am talking about. It is not going to be something like if I'm getting the error as 7.72, your error is coming 2 point something. No, that much difference we cannot afford. Okay. If it is going one way, 1 point up, 1 point down, then it's okay. That is fine. Okay. Now this next thing is matrix dot mean square error. And inside that, we are going to mention y-test and y-pred once again. You can see it is somewhere coming for me 87.32. Okay. Now what we have to do? Import numpy as np. Guys, you can do the same thing with the math module as well, but I usually prefer numpy. So simply I'm writing np.sqrt, and inside that, either you can save this inside a variable and call the variable, or you can call this whole line inside the np.sqrt. So square root error we are getting at 9.344. So what do you guys think? Which error we should move forward with? I usually go forward with mean absolute error because I can see everything is following is the correct case, correct? We don't have any sort of outliers. And outlier is not the correct term. Today I'll tell you, we call that as residuals, okay, in linear regression model. We'll talk about that, okay? So if all the number of data points, or let's say all the scatter points are coming in a straight line, I cannot see any sort of variation in my values. Let's say if one data point is a bit far, one data point is a bit far. No, I cannot see those things happening here. So I can say that I can move forward with mean absolute error. Okay. So this thing we have done till here. Now it's the time to answer the business question. Okay. So what was the business question? If I scroll this bit up, you will see that our sole motive is that the company is trying to decide whether to focus their efforts on the mobile application experience or their websites. Okay. So if you guys remember, this is multiple linear regression, right? Once it is multiple linear regression, how my equation of line is going to look like: y equals to m1x1 plus m2x2 plus m3x3 plus m4x4 plus c, right? Here sometimes we write c as epsilon as well. We will see something like this. Okay, they both are same thing. Here you call that as intercept, or in the case of linear regression, we call that as error. Okay, so since we are writing c here, you can see what is the value of c we are picking here? Mean absolute error. So can I write simply like this, 7.72 something? Okay, we already identified the value of c. Cool, done and dusted. Now what is the next thing we have to identify? We have features already there available in the format of x. x1 is one of my feature, x2 is another feature, x3 is another, and x4 is someone else. So another feature. What about this m? What I told you, this is the coefficient of linear regression feature, which means how important this feature is, or what is the importance of this feature, or how weightage this feature carries. Making sense? So higher the importance, so you will get higher the coefficient value. Let's say if you are getting the coefficient value as 100, for example, and here you are getting the coefficient value as 98. So you are going to give which one the more importance? This one. Okay. This is basic equation we are talking about. Normal equation, how we do solve such type of equations. If you see that if I write 2x plus 3y equals to 4. Okay, so we say that 2 times I'm going to multiply x, 3 times I'm going to multiply y, then I'm going to achieve the value of 4, right? So what is this? What is this 2? What is this 3? Can we say that it is nothing but the weightage which x carry and y carry? Or can we say that it is importance of x and importance of y? Similarly, this happens in the linear equation as well. Okay, so this is our equation of line or linear equation. We are trying to identify the value of m1, m2, m3, and m4. How we can find that? We have a method here available in the linear regression called as lm.coefficient. Okay, so let me check how in which variable I save my linear regression model into. Okay, this is lm, right? So I'm going to use lm only. lm.coefficient. If you use tab, you will see that this is the method that will help us to identify the coefficient of every variable. After writing this thing, I am trying to create a data frame that will store the coefficient of every feature, and it will give us the answer in the tabular format. Okay, so simply I'm writing pd.dataframe, unless it will look like an array and will not give you much sense. So I'm just trying to design it a bit more good manner. So I'm simply writing lm.coefficient. Okay. The next thing here is that I am mentioning the index of the data frame, where first I am mentioning df was my data, right? So I'm simply writing df.dtypes just to pick up the column names. So here the first name of the column is average session length. The next name of the column is time of application. Guys, I'm picking only those columns which are taking participation in the linear regression. Okay. The next column name is your length of time on website. And the fourth one is your length of membership. Okay. So this is the index, how it is going to look like. So the data will capture the value of lm.coefficient, and according to the column names, it will give me the coefficient value. Just let me check. lm.coefficient. This is my data. And I have mentioned everything. Oh, I forget to close the bracket. Now. Okay, just a second. I'm cutting this as of now. Let's see what this is going to print. Oh, got it. It is printing in the row format. Okay, can I make this series? One dimensional. Okay, let's change it to make it data frame only. We are having the coefficients here. Mentioning the index. Why this is picking the column name? No issues. Let's convert that into column itself. Let me store this data frame somewhere else, or I can modify it. I have to rename the columns, right? I guess we don't have columns variable here. Okay. Yeah, thanks for that. Now you can see average session length, time on application, time on website, and we are having the coefficient like this. Although I wanted this to come in the single column format, but since it is coming as one row, no issues. You can see average session length value for M1, it is giving me 25.65 something. Time on application, it is giving me 38.64. Time on website, time length of membership. Okay, so if I ask you that which column is highly responsible for the judgment of yearly amount spent, what is going to be your answer? You can say that it is length of membership because it carries highest importance or highest coefficient. You can say that higher the coefficient, we can say higher it is taking participation while the judgment of the target feature. Okay, so the highest coefficient we are having is for the length of membership, and the lowest coefficient you can see it is for the time on website. Whereas if I want to answer the business question, which my client was asking, that in which section do they need to invest more, in the application or in the website? What do you guys think? What you are going to suggest them? Why not website, guys? Just a cross question, okay? Since you are going to become a data scientist, you have to think in all the directions. So aren't you going to say that your website consumption, like people are using website very less, you should enhance your website bit more so that they can use website bit more, or maybe you will get a bit of profit in yearly amount spent? Can't we think in that direction? Okay, either you can say that people are using your mobile application more, try to enhance your mobile application, and you will get, there is a possibility that you will get more profit. Now the other way of this coin is you can also say that people are not using your website much. There is a possibility that you are having some bugs in your website. There is a possibility that they are facing challenges while using your website. To try to enhance your website with more might help you to gather more amount from the people. Okay, so since they were asking the question in such a way that whether to focus their efforts on the mobile application experience or the website experience, so for the safer side, we are going to tell them both options. But as I can see, this feature is more important, which means application feature right now is more important for the yearly amount spent. So I'm going to go with the higher coefficient. Since we are having two faces of the coin, okay, don't forget that. But we are choosing this one as of now because it is carrying higher coefficient. If they were asking me in such a way that which one to improve, right? They were asking enhance. They are already having good websites in their hand and they want to, let's say, classify, or let's say they want to make it more appealing. Okay, so in such a way, we can go with the application one. We can say that you are having more customers, they are using application more, and that is giving you contribution to your amount, whereas people are using websites comparatively very low. Okay, so you can enhance your application system, or let's say mobile application, that will help you to gather more crowd. Okay.